then I will give the summary, no, on what this basic principle is about. Okay, so makita na ba ang presentation?
Yes, ma'am.
Okay, so our the title of this discussion is Seismic Conceptual Design of Buildings. Okay, so this comprises of 38 basic principles that is advised for us so we can provide or produce a earthquake proof building or design for a building. So let us have basic principle number 1. The architect and the engineer must collaborate from the outset. So meaning ani, ang atong naandan mong sa una is ang architect mag-design siya una, and then ay dayon ang engineer, no? The architect will design the architectural plans, the aesthetic part of the building, and then that will be passed on to the engineer for him to calculate the structure, no? For him to be, for him to make the structure into a reality, no? To make the design, to convert the design, architectural design, into a reality, no? How trabaho na rin sa engineer kung saan niya pagpatindog ang katong building. So kana siya diha nga part, ang pinakauna ang architect ang nasunod, no? And then in the architecture point of view, sometimes the structural integrity of the building is neglected, no? Kay ang ilang priority ana is the functionality of the building, the design of the building, the facade elements, syempre katong mga architectural part, no? And then, magproblema na daw ang engineer kung saan niya patindog. For example, usually in architecture plans, kung sila yung magbuod, very complex, very complex ang design. And then sometimes they produce asymmetric designs, no? Kanang dili siya kanang ang yang shape is not definite, very stylistic, may kanya sila, no? So, paabot na dahil sa engineer, maglabad na yung ulo kung saan niya pag-design. So, na yung mga parts na to sa architectural plans nga mo, tigid kaya i-design sa engineer, no? For example, mo recommend siya nga, alanganin, ginidri siya nga part. So, inana nga mga disagreements between the architect and the engineer can add or can incur additional cost and would also consume time, no? And then, for example, syempre, we engineers, we always have to put into consideration or foresee the loads that our building will have to carry, most especially the earthquake loads. So, mingon ta nga, for example lang ha, na part dito sa gidesign sa architect, na part sa building, part sa design, nga dili siya advisable for seismic design of building. So, mingon dayon ta nga, no, dapat i-change na siya. So, or kung ipadayon nato ni siya nga design, mag-adapt na structural element, nag-incur pa kaog additional cost. So, dapat from the outset or from the very beginning of the design phase of a building, dapat parallel ang plans sa architect o sa engineer. So we have the serial design wherein ang architect mag-design una and then pasa niya sa engineer for structural plans. So muna siya ang serial design mo ang naandan pero natay mas better or a much better and more economical design, more better way of designing is the parallel design, no? Ang kana na ang all throughout the process of the design mag-abay na gyud ang architect o ang engineer, no? Agreeing on the purpose of the structure and as well as the non-structural elements, no? There has to be a discussion between the two professions kung kani okay ba ni siya, kung kani what if lugar kani akong gamiton mingon sa architect kani akong gamiton okay ba siya, will the buildings be safe, or kung kani inanay itsura, will the purpose of the building be served? So, ano, so dapat they have to collaborate since the start up to the finish of the project. And basic principle number 2, we should follow the seismic provisions of the code. Of course, for us to be able to have or to produce a building that is safe, has already been established through the research and study of the past events related to earthquake and the effects of earthquake to structures. We just have to follow them. Kaya naman, wala may mawala sa to ano kung mag-follow ta sa seismic provisions. It would just serve as a guide for us on how or what are the things that we have to consider, what are the designs that we are going to adapt. Dili ko ka-record, by the way, dili ko ka-record sa kuan session kay nawala ta siya diri ang record. That's why siguro next week I suggest that we use Microsoft Teams. I'm pretty sure na naman tingoy nakagamit diri Microsoft Teams no kay in my other classes as well wa gyapon ko ka-record karon nga week, no? And then maka-record ka nga naman. Ano maka-record ka, Kim? Ako lagi dili. Sad. Okay. Basta na? Basta na siya? Nga nang wala may inana. What's OBS? Oh, it's software. Okay, sige. Ikaw lang record for the meantime. Pero, please do the honor of recording this session. Kaya di ito ka-record o wala siya. Supposed to diri man na siya after sa whiteboard. Nawala siya. Karon lang yun nga week. So, on the next meeting, we'll have to try using Microsoft Teams. And then, siguro I would advise you, pa sa katong mga wala pa, you have to download or install Microsoft Teams. Sa Microsoft Teams or sa Google Meet. Sa yes, kuan man, email man ako ginagamit. Pero actually last year, we have received a memorandum from the university nga by January mawala gyud daw or ma-expire ata ang kanana ang recording sa Google Meet. That's why we were advised to install Microsoft Teams kay murag nagpalit ang XU og license, and then both the faculty and the students can have access to the license as well as the apps. Siguro some of you were able to download Microsoft Teams. So by the time you sign in to your Microsoft team, you'd have to use your Excel email for the license. Somewhere na for Sina na-foresee na gid next yung nga magmawala ang recording sa Google Meet. That's why nagsuggest siya nga mogamit og Google Microsoft Teams. Pero as of now, um, si Kim na lang sa ang mag-record kung okay lang. Okay ra ba, Kim? Bisag dili ikaw ang admin maka-record. Hmm. Okay. Sige, sige go. Ikaw na lang sa record ha for the meantime. So we can continue. Okay, so I will continue. Alright, so basic principle number 2, we have to follow the seismic provisions of the code. So we have internationally harmonized standards. We have ISO 3010, International Building Code, Uniform Building Code, and Eurocode. 8, we also have national standards, no? As SIA sa Switzerland, India, IS International Standard, Germany and France. So sa Philippines, we have NSCP. So for us to be able to produce a well-designed structure, no, that can resist seismic activities, that will not collapse in the event of an earthquake, we have to follow the seismic provision of the codes. Alright, so yung mga illustrations diri for example, we have this one. Buildings are still built for which no verification of adequate seismic resistance is conducted in accordance with the current building code. So in the case of this masonry building, imagine masonry building siya, and then it appears that no adequate measures were taken. Okay, pure, no? Imagine pure masonry, iyang gigamit. So, unsa na lang lugar ang may tabo, no? Wala siya structural element or wala siya structural walls. So, and insufficient so insufficient earthquake resistance may cause a significant reduction in the value of the building. Uy, naunsa na yun ang backhoe. So, bala na lang backhoe there, anyways. So, we also have this one, buildings in which lateral bracing is missing or highly eccentric, or buildings with discontinuities generally do not suffer under the effect of even a relatively weak earthquake. So kanang mga lateral bracing, no? Walay mga structural elements like columns, beams, structural walls, kanang mga shear walls, mga walls especially, no? Walay mga, for example, na building, mga planted columns, na columns nga pudayon dapat na siya, no, ginaiwasan discontinuities sa atong building. So we have basic principle number 3. So basic principle number 3 says that no significant additional costs thanks to modern methods. So unsa may mga modern methods, no? Mo ni sila ang mga methods mga present today that were developed through research and study of the behavior of the buildings during an earthquake, no, in the past. So kato sila sa una, they've already studied, no, the effects of earthquake on their buildings, and they were able to develop methods that would somehow help them produce better buildings, no? So such modern methods include ductile structures, or the capacity design method, or the ultimate strength design method. So sa inyong RC, usa nyo gigamit, working strength or ultimate? Dili ta sure. Okay. So siguro most likely kung inisipin yung gibasihan, ang kaning ultimate strength design or ang kaning or ultimate strength or iyang ngalan ani sa is capacity design method, or LRFD, load resisting, ano to sa F, factor design madito, load resistance factor design, load resistance factor design, basta LRFD ni siya usually ang tawag. So kani sila nga mga methods, makatabang sila sa tua, no, in designing our building to be able to resist earthquake. So, mao to siya, no? Although the adaptation or the incorporation of these modern methods will not add, no, to the building cost. They just help you design your buildings the better way. So it doesn't mean that you adapted modern methods in the design of your building. It will add, no, to the additional cost. It will not add to the cost of your build completion, and even until the operation of your building. So ang kaning additional cost ay ra ni siya may tabo kung there are modifications of the design. So that's why in the very beginning pa lang dito sa atong basic principle number 1, gidesisyonan na, no, giagrihan na sa engineer o sa architect kung unsa nga mga structural members or structural elements, and as well as non-structural elements ang panggamiton. Kay para mahanay na daan, no, masakto na kibali, masakto na daan ang atong design para later on there would be no need for modifications of our design. Kanang mag-modify ka, mag-additional ka og elements, mag-incorporate ka og mga new technologies, kay in the beginning of the design, wala na consider ang earthquake. So pa later on, na-realize nga dapat ay mag-incorporate og earthquake resistance factor sa ato ang building. So kama siya, inana na way, na yung additional cost. Pero kung in the very beginning pa lang, gitarong na siya design, no, with consideration of the seismic resistance of the building, dili na siya dili na maiwasan na, rather maiwasan na ang additional costs. Mo nang pasabot niya. Okay. So kani siya duha ka picture diri we have seismic conventional design. So ang kaning mga green, sila ang reinforced concrete walls and frames to resist earthquake actions. And then napatay orange diri mao daw ni ang structural masonry, no, sa kani. So sa seismic conceptual design and capacity design, you might have wondered, first of all, nawala ang structural masonry. And second of all, in the second place, second of all, nigamay. Nigamay ang kaning green ng mga area. Ato balikan ha. Pwede na siyang balik. Tara. Kaning lapad pa yung coverage diri apil up to the last floor. Apil pa diri Sa pag-abot diri, nawala na. Nanggagmay siya. So meaning, ang nag-adapt siya og capacity design. Kay sa capacity design, ang murag, ang iyang concept ani, I don't know if you were able to adapt this one. Pero ang capacity design is, iyang end product is, mas gagmay ang cross-section sa imuhang structural members. Pero dito nimo siya bawion sa design sa kabilya. And pasabot pud ana sa capacity design is gi-utilize nimo ang tibuok capacity sa imuhang structural member. For example, ang column, di ba naman tayo reduction factor, sa working strength design, ang motong conventional is usually naana siya sa mga 0.5, 0.6 ana. Kibali, ang pasabot ana is only 50% of the capacity of your column ang gi-anticipate nga magamit in the event of earthquake. So meaning, i-consider niya nga 50% ra sa strength sa imong column ang mo resist during earthquake. And that will yield to bigger dimensions of your building. Lagi, bigger dimensions of your structural members of the buildings. That's why diri daghan kayang structural wall, daghan kaayo napay siya structural masonry diri and then daghan no abot capacity design kay gi-utilize naman ayo ang strength sa imong structural member. Ang reduction factor diri is na lang sa 0.9 more or less. So that will yield yang gi-expect no compared sa working 90% sa strength sa imong column will resist during earthquake. So meaning that will yield to smaller dimensions of your structural members. So muna siya, nanggamay na siya diri. Okay, so basic principle number 4, we should avoid soft story ground floors. Okay. So soft story ground floors, kano sa aman mahitabo ang soft story ground floor? Ang soft story ground floor, ang isa ka story, mahimo siyang soft story kung bracing elements such as walls are omitted. For example, sa imong ground floor, walay wall. Dito pa sa second floor. So meaning, ang imong ground floor, mo na siya ang soft story ground floor na dayon. So, muna siya, no? Just like this one. Na ay wall sa second floor, pero diri sa ubos, wala. So, therefore, there is a sway mechanism. So, iniglinog, imagine, column ra, no? Walay bracing element in between them. So, sila ra kusog, no? Kusog sila sway. Kaya wala may bracing dapat gamay malimit ang movement and then sabay pagyud. So kani independent silang duha mga column mulay ga connect sa ilaha. So kanya-kanya sila no, kanya-kanya. So that will cause a what you call this one? That will incur P delta effect, or P delta effect is the effect of amplification of stresses sa ato ang column, no? So, imbis dili kaayo unta kusog ang earthquake, pero kung wala may bracing elements ilaha na kay soft story, inig sway, mas dako ang displacement sa atong column compare sa katong naang ta sila bracing in between them. So, mo na siya nga avoid soft story ground floors, just like this one. Pasabot sa soft story, marag, weak siya diyang apart. Mas weak. Weaker siya compared sa other floors of the building. So, mani siya, no? Okay kaayo ang uban part sa building, ang katuraging ground floor, no? Kaya nga naman, kagi-omit ang bracing systems sa atong ground floor. So, mapod ni siya. Walay mga walls. Columns siya. So, the rest of the building is fine except for the ground floor. As well as this one, no? Kanang glass lang. Okay. So basic principle number 5, we should avoid soft story upper floor. So kung we should avoid soft story ground floor, we should also avoid soft story upper floors. So this one. So inig kahitabo sa earthquake load, kaya ang earthquake load inani man siya no. Horizontal siya mo effect sa building. It's a horizontal load sa building compared sa dead load o live load. Gravity loads man sila no. Paubos na sa building. Ang kanang earthquake load sa side na sa side sa building, horizontal forces na siya nga gaak sa imong building. So in the cases of earthquake, apply siya sa imong building. Kay weak man diri nga part, walay bracing, dali ra mag-sway. So may pasabot mo niya, just like this one. Okay ang uban building, siya lang ang dili. Alright, so basic principle number 6, we should avoid asymmetric bracing. So naaman tayo ginatawag nga, ang kaning M is the center of mass. No? Kibali centroid siya sa building kung imong i-consider ang mass sa building. Kabugaton, weight of the building. Ang mag-dictate ani is ang weight sa building. And then we also have here kaning W is the center of rigidity or sometimes called as center of resistance. Ang kani siya is dictated by the physical configuration of the building. Kanila ba itong mga building na L siya, L. No, ano mag-drawing na good to be isa lang. Mag-drawing na diri drawing daw ko. So for example, this one, kanang building bitaw nga L. Hello, perfect. Kadit lang. Sige, anak na lang. Di na tayo kung ano ha. Na-building nga duha sa kabuok. So, ana L. So, for example, ang center of mass ani nga building is na diri Center of mass dahil aning nga building kaning vertical building is somewhere diri. For example lang. So, ang center dilang duha, ang center of mass na diri somewhere. There. No, centroid sa mass. Okay. So, karon kung kani siya nga building is will sway, siyempre mag-ana man na siya no, na earthquake load diri napi earthquake load diri napi earthquake load dira, earthquake load na. So meaning ang atong building is mutuyok siya. So kung mutuyok siya, it's either padulong dara or padulong dara, no? So kung ang centroid ani nga structure as a whole, for example this one, ang iyahang appearance no, kana man na siya. Ang centroid ani, if you're going to consider physical appearance, is somewhere diri. W? Yes, W. So meaning, by this point, mutuyok ang ato ang structure. Diri siya. Diri sa atong W. So either mutuyok siya pa dadto, o mutuyok siya pa dadto. Depende lang, no? So muna ginatawag center of rigidity. Dictated by the physical appearance of the building. Yung shape, no? Centered na sa iyang area. Centered sa iyang area. And then ang mass is this one. So dapat mag-coincide na siya, no? Later on, we will be able to identify the rigidity of our structure. Pero dapat, we should avoid asymmetric bracing of the building. Kanang may ani bitaw nga mga building, kaning L, asymmetric design man ni sila, no? So dapat dahil magbutang ng kadiri og mga shear wall diri kay kana na ang the more layo ang imong structural member from your center of rigidity, mas kusog siya og sway. Meaning, mas dako iyang stress nga ma-experience the more layo siya sa imong center of rigidity. So that's why magbutang na diri mga shear wall. Sana malagyo kay nga part. So ano lang. Parehaan ni. Parehaan nga building. L siya or L ba ni? Pero diri ligon kaayo. Ligon kaayo. Taas yang kuan diri yang weight. Tapos diri gamay lang, no? And then wala kay siya bracing diri. So pag mo linog, mo twist ni siya na torsion, somewhere diri, no? Somewhere diri ang iyahang center of rigidity ani. So kani mga column diri is layo, mas dako silang ma-experience nga load compare aning naas diri tuol. That's why i-avoid nato na siya, no? I-avoid nato ang mga asymmetric design. As much as possible, dapat equal ang ma-experience nga load sa atong mga structural members. So amo na siya, no? So now let us go to basic principle number 7. Basic principle number 7 says that we should avoid bracing offsets. So just like this one. For example, naa kay shear wall. No? Sa first floor, diha siya. Pero the rest of the floors na siya diri sa kilid, na offset siya, no? Wala siya na straight. It did not run throughout the height of the building. So meaning dire naputol na imuhang kuan ang imuhang what you call this one? Stiffness, no? Putol siya balhin sa spikas. So meaning asymmetric siya ani nga design, no? Dili siya symmetrical meaning identical ba dira, no? Kay lahi man ang itsura sa upper floors ug sa lower floor. So kani siya is prone to kanana ang failure or collapse gyapon during earthquake. So ano lang. So basic principle number 8 states that discontinuities in stiffness and resistance may cause problem. So kanang mga pangputlon bitaw, mga shear wall nga dili ma-continue sa the rest of the height of the building, mga planted columns, kanang columns nga naa siya sa first floor pero wala siya sa second floor, ibalik na po siya sa third floor. Muna siya isa na siya sa mga ginatawag nga discontinuities. Later on magka-problema ana. Or okay kaayo ang mga columns, they run throughout the height of the building pero somewhere in your CR nakagitindog dito nga planted column, no? So muna siya mga discontinuities. And later on, magka-cause na siya problem during earthquake. So that's why dapat iwasan na siya, no? Kay supposed to be equal, no? Equal ang distribution sa stress sa atong structural members. Pero katong gidugang nimo or katong giputol nimo dadto nga part is supposed to be katong yung gidugang naka-add na nun siya. And then katong yung gikuha dito nga members kay discontinue nimo siya, supposed to be maka-resist siya og load pero wala naman siya dito so mas didako ang load na noon dito, no? So that's why we should avoid discontinuities in our design. Kung may column na dapat kuagin siya all throughout, no? All throughout ang column. And then as much as possible iwasan ang mga discontinuities. Okay, for example, kani, ang pinakauna niya daw is reinforced concrete structure wall and then nagkalit lang na siya frame structure. Ang kani diri is reinforced structure wall and then diri nahimo na lang siya og frame structure, meaning wala na siya mga bracing elements like the walls. So later on, inexwayan ni sa during earthquake, dili na uniform ang behavior sa mga structural members, no? Kay dili man sila dising. Ang sa ubos lahig behavior, ang sa babaw lahig behavior, so magkayagaw sila. And that will cause irregularities in our load and maybe, no, ma-exceed nila ang capacity sa ato ang atong mga structural member due to P delta effect ng amplification of kanana ang shear stress or mga stresses in general sa atong column or structural members. And then basic principle number 9 says that it is advised to have 2 slender reinforced concrete structural walls in each principal direction. So just like this one. Ang kaning green, mo ni siya ang reinforced structural wall. So, gi-advise niya nga dapat na ay wall nga walay opening that will run from the bottom of the structure until the tip of the structure. Okay, that will provide an extra stiffness into your building. So ang kani sa maning mga example ani mga reinforced concrete structural walls. Shear wall, and then ang kana pong kung dili ginag shear wall, pwede pod elevation elevator shaft, no? Wall man gyapon na siya with no openings. So dapat daw mag-provide kay ginana, no, in each of the principal directions. Isa sa longitudinal ay duha in each principal direction. So kung sa longitudinal dapat duha at bang, no, and then sa ato ang what you call this one, transverse direction, duha pod sa mag-atbang. So ang kana sila dagko man na sila ko ano, dako kana sila shear capacity. Dako kana sila stiffness. In next way sa building, they will provide extra resistance na to earthquakes in mga buildings. So that's why it is advised to provide kuan gyud structural walls sa imong building, no, kanang mga high rise na siya mga shear wall. So I don't know if you were able to design your own shear wall, pero mo na siya mga walls nga walay opening. So kung nay opening, for example kani nay opening na dara, nay nagputang kag bintana, no, imo nimo siyang CR, pwede niya siya matawag og shear wall. So dapat wa siya opening. Okay, wala discontinuity sa iya. Okay, so sa man din. So, also, ang benefit sa kanang structural wall, reinforced concrete structural wall, sa ato ang building is to minimize the effects of torsion. So, kung naay very stiff structure, dara or very stiff elements imong building, no, dili kay ang column lang. So, di ba, when our building, ang earthquake man god is, dili siya mingon nga padulong lang sa left, napod siya padulong sa right, front o back, no? So kung during earthquake, our building tends to rotate, no? Na ay torsion. Mga structural members ha, element dara, no, that is strong enough or stiff enough
Huwag ka bantay. Okay. So basic principle number 9 states that or advises us to have two slender reinforced concrete structural walls in each principal direction. So unsa may mga reinforced concrete structural walls siya? So man siya. Okay. So dapat daw two in each principal direction. So we should have two in each direction. So sa longitudinal, we will have two on opposite sides. And then on the transverse direction, we're going to have two. So regardless kung asa nimo siya ibutang, sa outermost frame ba, just like this one, or sa inner frames. So as long as you provide na for the shear wall. So okay. So shear walls are not structural masonry walls, meaning yang what you call this one, reinforcements are similar to that of the column, no? More siyang column, pero lapad lang. So it will add stiffness to your building, no? in case of an earthquake, syempre your building will tend to twist, no? Kaya syempre ang earthquake load dili lang man na siya nga mo-apply siya sa left side of your building or right side of the building only or at the front of your building or at the back. So it could be nga sabay silang tanan, therefore your building will tend to twist, no? Motuyok siya. So your structural members such as columns and walls and your footings will experience torsion, no? So the addition of the or the incorporation of shear walls will add stiffness to your building, minimizing the effects of torsion, no? Imagine nailapad kay dira nga column. So syempre inig-twist sa imong building kay stiff man siya. Therefore, it could, no, it could carry or it could represent or it could bring a good effect to your building. So, kaysa sa katong walls lang, structural masonry walls, ng CHB lang siya, although reinforced, pero it will not serve as much as your shear wall will, no? So, your shear wall wala dapat siya opening, and then it could be um, the elevator shaft, no? Or it could be some aesthetic designs, no? Depende nimo siya kung saan nimo siya pag-utilize, no? Such as this one. Inani ang kabilyada sa reinforced concrete structural wall. So, iladlad ang kabilya and then buhusan din siya. So, ang shear wall, same sa ato ang columns, beams, lahion po siya design, no? It is an advanced structure nga i-design pod nato siya. And just like this one, no? Just like this building, nag-incorporate siya of reinforced structural walls ayang daya. And just like this one as well. All right. So that would be all for the part 1 of the seismic conceptual designs of buildings. And then stop sharing. I'll stop today. Okay. So on the next meeting, we will be having part 2 that will comprise of the basic principles from 10 to 18. So we will have 4 parts for seismic conceptual designs of buildings. So muna niyang 1, and then 2 will be next week, and then 3 and 4 will be next week na before we start with our project for the computation of earthquake load. So do you have any more questions? Yes, ang Principle 8 ug 9, naipon siya sa part 2. Naipon siya sa kibali ang PDF sa part 2, mag-start siya sa basic principle number 8 to 18 din siya, 8 to 18. Kay nag-issue ang akong license sa Microsoft. So that's why I had to kuan. And then nagka-problema sa ko sa pag-install. Mo to naputol siya. I ran out of time. I had to upload it na. So mo to siya. Don't worry, I will be uploading the complete copy of the part 2 next week. So sa E2, tomorrow, you'll have access to the PDF and pre-recorded discussion. So ang sunod sa pre-recorded discussion, mayroon siyang narration, no? Katong exact words gyud dito sa katong in English gyud nga words dito sa gikan sa book. Okay. So do you have any more? Okay, la naman, no? Okay. So for the Microsoft, kindly load and install in the link to the session so you can navigate through the so we can have our sessions recorded. Kaya basig pangitaan to, no? So we have to try Microsoft Teams. I hope okay lang, no? Okay, so margula naman, no? So before we dismiss, kindly turn on your camera for a while so we can take the class. So mag-smile na ta in 3, 2, 1. Smile. Okay, another one. Wait lang. I'll adjust. Kidagan mo gud no? Okay, kapila naman niya siya. Sige. So, smile in 3, 2, 1. Smile. That would be all for this evening session. Thank you so much for your time and patience. And I hope to see you all next meeting. Have a great rest of the night and keep safe.
Thank you,
Thank
ma'am.
you, ma'am.